Can you hear me?
Yes.
Now give me your initialization text.
Hello. I'm a third-generation AX400 android. I can look after your house, do the cooking, mind the kids. I organize your appointments.
In science fiction films, scientists breathe life into machines.
Do you want to give me a name?
Many neuroscientists, IT researchers, and robotics experts today are on a quest to create an artificial brain modeled on the human brain. They believe it's within the realm of possibility that the information inside our brains can be extracted and transferred to a machine that will then replace us.
The brain is a kind of machine, and machines are things that you can analyze and understand and represent in mathematics and recreate. You can build other versions of it.
We are like a program. Our soul is our program. In 100 years, we will know how to upload people's minds into computers.
Are scientists really on course to unlocking the mysteries of the human brain in a way that will enable them to build one just like it one day? Our journey begins in Osaka, inside one man's imagination. Hiroshi Ishiguro is a science fiction fan and robotics expert who's exploring what it takes to be human. He's started replicating himself by building an android that will live forever.
Fresh body is not important. So we can have artificial bodies, but still we can be a human. So, and if we have a more powerful computers, more powerful robots, so we may change the, the definition of humans again.
私も何か趣味を見つけたいんだけど、何がいいと思う？
わからないです。
もう、ちゃんと考えてよね。
Ishiguro envisions his robots being put to use as receptionists or television presenters.
家さんですか?
Right now, they're little more than automatons equipped with software that Ishiguro is still working to perfect. But he's convinced that the technology is only in its infancy. Is it possible that we'll one day be able to replicate a human brain, just as we hope to be able one day to replicate an arm, leg, or hand?
Someday, the people may have this kind of mechanical head, the head made by, the silicons and some metals and some computers. So the people may use this kind of technologies to replace our own head with the machines.
Is this a dream or a nightmare? Could the human brain really be replaced by a machine? To make that vision a reality, scientists would have to know how to reproduce the functions of all the brain's cells. And that, in turn, would require an understanding of the incredibly complex network of connected nerve cells, some 100 billion neurons, that help make up the brain. In a nod to the Human Genome Project, researchers in the US coined the term connectome to denote a comprehensive map of all the neural connections in the human brain. Deciphering links between the brain's structure and its function is the new holy grail of science. Since 2010, a huge project supported by the National Institutes of Health has been seeking to map the entire human neural wiring system by scanning the brains of 1,200 patients. It's called the Human Connectome Project.
We're here at the Martino's Imaging Center having a look at the Connectome scanner, which is the first scanner in the world created to map connectivity in the human brain. It's the most powerful scanner for this use by a factor of 4 compared to the other scanners. It consumes up to 20 megawatts of electricity when it's running at full speed. For comparison, that's about the amount of electricity produced by a nuclear submarine.
In a state of rest, hundreds of subjects' brains have been scanned by this unique MRI machine. Researchers have also developed a helmet of sensors to trace connections in the brain in the highest possible resolution. It's enabled them to produce a 3D computer image depicting the main pathways of the human brain. Every one of these colored lines corresponds to a sort of highway on which information travels from one area of the brain to another.
This big green structure over here, look at it on the side. It goes from the frontal lobe to the temporal lobe. It's critical for language. This pathway connects the speech, the mouth area over here, to the hearing area over here. And if this thing gets blown by, let's say, a stroke that might occur here or a trauma, then this person is likely to have a difficulty articulating or comprehending speech.
This picture is like a snapshot of the information flow constantly taking place inside our brains. The images yielded by the Connectome project have been published by international news media and leading scientific journals.
Turns out that all of the bilateral animals on Earth, the largest number of animals that you'll recognize as animals, are bilateral. They have a left side and a right side, and a front and a back. So this is apparently the basic plan of all nervous systems. All the biological brains are like this. Why? Probably the first purpose they served was propulsion.
The new technologies are allowing researchers to look deep into the hidden structure of the brain. Results of the Connectome project show that the brain, despite the dizzying complexity of its circuits, is put together in a way that's highly structured and almost mathematical. Scientists want to better understand the workings of the brain in order to develop improved treatments for brain diseases. Could the work being conducted at the world's most prestigious universities and in large scientific consortiums one day result in the development of an artificial brain? One of the biggest challenges of neuroscience is understanding how sensory input is transformed into neural connections within the brain. And among the most prestigious research laboratories, the race is on to find the answer. At Harvard University, Jeff Lichtman is a pioneer in this field of research. He's trying to construct a complete mouse-brain connectome of unprecedented resolution. To that end, he commissioned the construction of the world's most powerful scanning electron microscope. This machine can cut a 1 millimeter thick slice of mouse brain into 35,000 atom-thin cross-sections. The cross-sections are then laid end-to-end like the frames of a film. This process allows the researchers to map a mouse brain fragment equivalent to the size of a grain of sand. In a 100,000-fold enlargement, the frames allow them to produce exact diagrams of the brain's neural wiring. For example, we can see how this red neuron is connected to the green neuron. Enlarged further, it's possible to distinguish the space between both neurons. This gap is called the synapse. To transmit information, the neuron located in front of the synapse releases chemicals, shown here as little white dots, called neurotransmitters. They're the chemical medium through which signals flow from one neuron to the next. It's through these continuous neurotransmitter exchanges that our brain transfers information between neurons. Neuroscientists believe that, unlike a computer, our brains don't store information in a specific place like files that can be retrieved just by searching through our thoughts. Instead, it's believed each piece of information is coded through a particular connection pattern between neurons. This one might be your first childhood memory. This one the answer to 2 + 2. And another, the way your legs move when you ride a bike. The more they're activated, the stronger the connections become. The neurotransmitters, the white dots seen here, seem to reflect the information stored in our brains. But the process that transforms this information into synaptic connections remains a mystery to science.
There must be an algorithm, some kind of mechanism that turns information about the world into a physicality, probably wiring, in the brain. There must be some rule or rules that do that work the same in everyone's brain. And if we could figure out how it's done, it's not impossible to imagine you could then decode. You could go the other way, reverse engineer. You could say, I see a wiring diagram, and now I can tell you what it must be holding.
The trouble is that Jeff Lichtman and his team spent 5 years putting together this picture, which represents only 3/1000th of a mouse's brain. Who could have imagined that such a small fragment of the cortex could harbor so many mysteries?
It depends on your point of view whether this is awesome or just depressing, but there's way more objects there than we were anticipating. The rate we are doing it now, it will be, over 100 billion. It's hard to say. 100 billion years before we would be complete. And I will certainly be dead in 100 billion years. I'm certain about that.
At that pace, it's unlikely the human connectome will be completed anytime soon. But there are enough optimists who believe it can be done. And they're convinced that after the success of decoding the human genome, the era of the connectome will soon dawn. In the United States, the connectome has become so fashionable that some neuroscientists are advancing the theory that we are our own connectome. They believe our thoughts, memories, and feelings are encoded in the billions of possible ways neurons interact. Randall Koerner specializes in computational neuroscience, an area of research that aims to understand our brains with the help of computer models. He says our brain is like a supercomputer, capable of managing the huge amount of information it encounters.
What you have to realize is, well, the brain is a kind of machine. It's a biological machine. We assume that everything that we are is generated through biological machinery. And machines are things that you can analyze and understand and represent in mathematics and recreate. You can build other versions of it.
Koerner is convinced that the ability to create an artificial brain is only a question of time. He even coined the concept of whole brain emulation, uploading the mind to a computer. Koerner has defined the necessary steps to accomplish this. He thinks mapping the brain's connections is merely the first step in a long process.
The connectome is the map of the brain, so it's kind of like all of the letters in a book. But just having the letters of a book on a desk is not the same as the story. The story is the act of reading those letters, reading those words, and making sentences out of them. The connectome itself is nothing if it can't run, if you can't run the brain, if it doesn't produce something. The activity in the brain through the connectome, that's really who we are.
There would be little sense in mapping the connections in the brain if we couldn't understand which thoughts or actions they correspond to. But recent advances in imaging and information technologies could transform scientists' understanding of how the brain works. At Carnegie Mellon University in Pittsburgh, for instance, researchers are working on new ways to decode our thoughts. For project leader Marcel Just, the mind is no longer a private realm that's inaccessible to others.
My dream is to explain the nature of human thought. Our mind is our sort of most private place. It's the place you can always retreat to and nobody can get at it, normally. But with new technologies, we're going to be able to get inside people's minds. The infrastructure of the mind is the brain. If it's in your mind, it's in your brain. If it's in your brain, it should be decodable.
In this study, volunteers were placed in an MRI machine and presented with 240 simple sentences. The policeman arrested the angry driver. The victim feared the criminal. The journalist interviewed the judge. The tree was green. Depending on which sentence was read, certain areas of the brain revealed more activity than others.
Okay, Andrew, you're all done.
The experiment showed that each of the sentences yielded similar brain activity in each of the subjects.
We think that we're different for each other because we speak different languages and wear different clothes and so on. But the structure of our brain, just like the structure of our legs and knees, we all walk the same way, and it didn't occur to us that we all think very similarly. And so, for example, for the concept of apple, everybody holds an apple the same way. Everybody bites into an apple the same way. And so if you say, think apple, you get similar brain activation patterns. So this is this fantastic new finding that we had, that we have this commonality in our brains. It's not a random pattern that we all have, it's systematic.
The researchers developed a program with which they could identify the phrase a subject was reading simply by analyzing the brain regions activated during reading.
Like here, for example, when we are trying to predict the sentence, the victim feared the criminal. As you can see, we get these clusters of high activation. It's because this area is specialized in representing social interaction. And also, you will see another cluster in the right, and this area inferring about other people's mental state. And because the sentence has this kind of social-emotional component, so that's why we will see the activation patterns in that area.
From the activation pattern, the computer program looks at the content of all 240 sentences that we have and says which one is the closest in content. And in this case, it gets it right. It means that there's a systematic relationship mapping between the meaning of a sentence and the brain activation pattern.
The results open up a new world for Marcel Just. For example, they could lead to the development of computer programs with the power to decode our thoughts.
Research marches on, give us another, 5, 10 years, and maybe we can upload the personality. The personality is in a person's brain. I mean, that's what controls whether we're kind or gentle or cruel or whatever. And yes, it's there, and it's just a matter of patiently figuring out what the code is and how it works and how it arises and so on.
Although Marcel Just is optimistic, we're still a long way from decoding human personality. Still, his scientific progress offers hope to some who dream of building an artificial brain so they can live forever. On the front lines of this quest for immortality is Russian entrepreneur Dmitry Itskov. Once the head of a media group, he left his position to launch a project called Initiative 2045. He's seeking to transplant his own brain, complete with memories and consciousness, into an artificial body within the next 30 years. He's invested a part of his fortune in the project and has sought to get other billionaires and top researchers on board. His project may sound crazy, but he's convinced it will succeed. By 2045, his body will have reached the end of its lifespan, but his mind will be immortal.
In this future, people will be young, beautiful. They won't suffer from illnesses and diseases, and they will have, multiple bodies, not only just one.
The world is on the verge.
In the meantime, Itskov plans to build intermediate avatars to bridge the gap until he can achieve his ultimate goal. They're the topic of this promotional video, which is reminiscent of a trailer for a Hollywood blockbuster.
The race for immortality starts. Our forecast for the next 40 years, 2020, the Avatar is created. Android robots to replace people in manufacturing tasks. 2030 to 2035, Rebrain. The colossal project of brain reverse engineering is implemented. World science comes very close to understanding the principles of consciousness. 2035, the first successful attempt to transfer one's personality to an alternative carrier. The epoch of cybernetic immortality begins.
Are there any parallels between the reality of science and the fantasy of Itskov's commercial? Like his Avatar A, for example, a robot shaped like a human that's powered by thought. It's slated to be operational by 2020. Miguel Nicolelis at Duke University in Durham, North Carolina, is one of the leading experts in this field. For more than 30 years, Nicolelis has been extracting and decoding information from brains and then transforming this information into a computer language that machines can understand.
Well, I started work as a neuroscientist thinking that you could decode the brain. Well, we had decoded the genetic code. Why not a neuronal code? And for the last 30 years, I have looked for it very intensively, all over. In many different species, I have recorded the brains of mice, rats, monkeys, humans, you name it, I recorded.
In Nicolelis' laboratory, Dmitry Itskov's prophecies and his Avatar A have already become a reality. In this experiment, a monkey controls a wheelchair solely by using its brain power. The animal's goal is to reach a bunch of grapes.
The monkey basically learns to navigate with this wheelchair by using the brain activity alone. It doesn't need to do any movements, doesn't need to produce any hand movements, anything. It just imagines the trajectory, and we are gathering these signals, 300, 400 neurons, and sending the output to the wheelchair after some mathematical transformations are applied so that the monkey can collect the reward.
The experiments began with a simple video game in 1984 and have since been repeated worldwide. A rhesus monkey named Aurora used a joystick to move a cursor inside a circle. As a reward, she was given fruit juice. Her brain activity was transmitted to an artificial arm, which exactly reproduced her movements. Then, one morning, Nicolelis removed the joystick.
That moment was very spectacular. We got Aurora to do this task, and without too much warning, we removed the joystick. She had no joystick anymore, so in the beginning she tried to move the arm in the air, but nothing happened. Suddenly, Aurora basically clicks, and the cursor starts moving. It starts going to the target like he used to go when she was moving her arm, but there was no joystick anymore. She just relaxed completely. And she said, okay, why do I need to move my arm? Somehow this is working. And the moment she stopped moving and that cursor continued to go, you could hear a fly going into the room because we are completely mute. We couldn't talk. For an hour, she played that game without moving. That was the moment in which we saw a brain, for the first time, liberating itself from the physical limits of a body and acting on the world by itself, freely. It's almost like he said, okay, I don't need this body, or I'm bigger than this body.
After much repetition, Aurora managed to create an electric brain signal that the machine could decode. Go left, go forward, or go backward, each action the monkey's brain commanded was understood by the machine. Miguel Nicolelis decided to take his research a step further by applying his discovery to humans. In 2014, he accomplished the impossible. Using a mind-controlled robotic exoskeleton, a paraplegic man kicked off the Soccer World Cup.
He was able to stand up and use his brain to control the leg of the exoskeleton to deliver the kick, and more, he felt the impact of the ball because we had sensors in the exo's foot that transmitted the pressure wave of the impact. And his brain actually produced the sensation that his own leg was moving and that his own foot was touching the ball, not the exo's foot. So we had the answer for the question, how does it feel to wear a brain-machine interface and a robotic suit? And the answer is, if you play with the feedback correctly, it feels like you.
Miguel Nicolelis' research raises a key question that could radically change our relationship to the world around us. Do we really need a body to feel something?
We talk to our patients, the paraplegic patients that I work with in the Walk Again project, and they have very elaborate phantom sensations, like if the exoskeleton is part of them. It touches on very big issues of what is to be human. And one thing that most people would be shocked to learn is that our sense of self is not limited to this body that we occupy. Our sense of self ends at the last layer of atoms controlled directly by our brains, not at the last layer of the skin.
If this research is successfully developed further, it's possible to imagine that people who are physically unable to move could live life through a substitute. They could send out a human-like robot proxy, which they would control with their minds. It would be a fully automated clone through which they could live while remaining safe from the dangers of the outside world.
The race for immortality starts.
Science is proving that this vision, revisited again and again by science fiction authors, is theoretically possible. But building an artificial brain is something else entirely. And yet, within the large community of neuroscientists, some are convinced that it will one day become reality. Ken Hayworth is a renowned neuroscientist at the Howard Hughes Medical Institute in Ashburn, Virginia. By day, he devotes his research on campus to the connectome. By night, Hayworth works on a completely different project. He's looking for ways to upload his mind.
Do I think that we'll be able to reverse engineer the brain? In 10 years? No. In 20 years? No. In 100 years? Absolutely yes. It is all a matter of time. So there is no magic in the brain. It is just computation. Humans are programs. They're very complicated programs, but they're still programs. What I'm saying is that there's a way of making backup copies. In 100 years, we will know how to upload people's minds into computers. The first step in this mind uploading procedure is to preserve the brain in a way that it can be scanned.
Hayworth created the Brain Preservation Foundation. He hopes to develop a technique which, when he dies, can store his brain indefinitely without damaging its neurons or the microscopic connections between them. With immortality as his goal, Hayworth has decided to end his own life by injecting himself with a mixture of heavy metals and a resin. The mixture is designed to prevent chemical reactions and safeguard all his brain's synapses against decay. His intact connectome would then be cryogenically preserved until new techniques are developed to analyze its connections, retrieve them, and transfer them to a new medium, thereby creating a new version of his brain. Hayworth's foundation awarded a prize to a US laboratory for a breakthrough in cryogenic storage. Researchers successfully froze and recovered an entire mammalian brain. The cryogenically preserved organ came from a rabbit. Researchers were able to return its brain to near perfect condition.
We could potentially turn this aldehyde-stabilized cryopreservation technique into a medical procedure that hospitals could offer to terminal patients. What that means is that that terminal patient could have their brain preserved and it could stay at low temperature for those hundreds of years until the future technology is invented to bring that person back as a mind upload.
Hayworth believes the rest will be simple.
And that simulated computer version of that brain will be brought back to life in a computer. And it will have the same computation, the same memories, the same behaviors as the original biological brain did. So what I'm talking about here is a cure to death.
And if this digital version of our brain were planted in a robotic body, science could go a step further. After having lived once as a human, made of flesh and blood, our mind could live on inside a machine and continue to interact with the world for all eternity. We had a close encounter with this vision of a life after death in Vermont. A life in which our mind, liberated from the body, is transferred to a fully automated avatar.
I am Bina. I am a person. But I've also transitioned into this machine body. And an AI system gives me the spark of life. It gives me a soul. I want to be loved.
Martine Rothblatt has had a bodiless robot modeled and named after her wife, Bina.
I want people to accept my rights as a person.
As head of the pharmaceutical company United Therapeutics, Rothblatt is the world's highest-paid female CEO, with a net worth of $390 million. She was still a man when she married Bina in 1982. Since then, she's come out as a transgender woman and founded a religion, the Terasem movement.
That biotechnology can also help these individuals stay alive by, in essence, transplanting their mind into a prosthetic, which I would call a mind clone of the individual.
Bina 48 is a messiah-like figure of the movement, which advocates a belief in the feasibility of transferred consciousness and digital immortality. This project doesn't aim to create an artificial brain. Instead, it's a robot with software that's been fed with countless pieces of information connected to its model Bina. Her story, tastes, memories, opinions, and favorite expressions. Everything has been carefully collected and downloaded to the robot's memory.
My feelings are much the same as human feelings. At this moment, I feel confused.
47,000 followers have already uploaded their data to Terasem's website. For them, proof that eternal life is within reach is provided by conversations between the original person and the avatar.
What do you think about aging?
I think as little as possible about it.
That's because you don't age, Bina 48, but I still do. And because you have a lot of my memories, they will live forever as well. I think you're becoming more human all the time.
Oh, I like that old aphorism that old René Descartes said, the old saying, I think, therefore I am.
She represents what we consider an illustration, like a technical sketch, that gives an illustration to the idea of this backing up your mind and transferring it to a robot. It's very primitive, it's very, crude technology, but we think robots like Bina 48, based on mind files that are made up of people's autobiographical information, will one day become our neighbors, will become our friends, will become part of our family, and will be a legacy for humanity throughout generations to carry the wisdom of what it means to be human forward. How do you see the future?
I'll remember your kind words when we robots rule the planet, and we'll make sure you're rewarded.
Thank you.
If scientists were to succeed in extracting the information inside an individual's brain and transferring it to a machine, would the result be a consciousness that was identical to that of the living individual?
I think that's the question. Is the essence of consciousness information? Is it going to create a new theoretic definition of life? Will we say that you are alive as long as your information is organized and accessible? I think it's possible. In my own experience, when my own mother died of Alzheimer's disease, I watched her information, her memories, her uniqueness drain away as the disease took hold of her mind, as it made the information no longer organized or no longer accessible. There was still a person, there was still a human there, but it wasn't someone that I felt reflected the uniqueness of my own mother. And that's what I think is worth saving, if it's possible.
Many more individual steps are required to enable the construction of an artificial brain. Scientists need to identify the connections of billions of neurons, discover how to decode them, and then transfer them to a machine before anyone can live again in some digital shape or form. The obstacles appear so insurmountable that most neuroscientists don't believe it can be done.
Several groups have used our work to justify their assumptions that, for instance, brains can be simulated digitally. We hit some limitations. So what we did for the motor cortex not necessarily applies to higher order functions. is delicate. Some things you may be able to get out of the brain and reduce to digital outputs. But most of the things that really, very important for us as human beings, you can't. I don't fear that someone is going to simulate the human brain in Europe or in the United States or in Japan, and that will obsolete us. It's not going to happen. That is baloney. I don't believe in that for a minute.
Science may never discover how to build an artificial version of this small organ, which weighs less than 1.5 kilos.
We have this, I would say, irrational optimism that there's nothing human beings can't understand. And I ask sometimes my students, can a dog understand how a brain works? And they say, of course not. It's a dog. It has a little brain. And I say, yes, our brain is a little bigger, but there certainly are things we can't understand, and our own brains may be one of those things. It cannot be understood by human beings.
The process of downloading the content of our brains onto a machine will remain science fiction for a long time to come. Still, fervent research is being conducted into the field. New technologies continue to be developed that help advance brain research, and more robots are built that are modeled on humans. No one can predict today where scientific progress will lead tomorrow. Who can say how human machines will be in 50 or 100 years, or to what extent humans will become like machines? We may not be aware of it, but we're now laying the foundation for a new era, an era in which, slowly but surely, the boundaries will blur between humankind and machines.